Hey guys, so today what I'm going to talk about is prime numbers, and I'm also going to be talking about the prime number theorem. So to start off, we're going to first talk about prime numbers. The definition of a prime number is a positive integer that is not divisible without remainder by any integer except itself and 1. Some examples of prime numbers are 2, 3, 5, 7, 11, 13, and there are many more. There are an infinite amount of prime numbers because there are infinite amount of numbers. One thing that is similar between all prime numbers is that they can only be divisible by 1 or itself. So, the number 7 can only be divisible by 1 and 7. Also, all prime numbers are odd except the number 2 because all even numbers are going to be able to be divided by the number 2. In about 200 BC, a man named Eratosthenes invented an algorithm to calculate prime numbers, which is called the Sieve of Eratosthenes, which he named it after himself. So, the most common use of prime numbers in the world today is in cryptography, which codes many different types of computers, video games, and other things electronically. So the next thing that I'm going to talk about is the prime number theorem. The prime number theorem is defined as the theorem that the number of prime numbers less than or equal to a given number is approximately equal to the given number divided by its natural logarithm. The men named Jacques Hadamard and Charles-Jean de la Vallée-Poussin in 1896 proved that the prime number theorem was true, but a man named Adrien Marie Legendre, who was a Frenchman, discovered the prime number theorem. This is the formula of the prime number theorem. The x's represent the missing numbers or the numbers you need to plug in for the problem. So, if you wanted to find the number of prime numbers between 1 and 100 trillion, you would find that, so you would plug in all the numbers you would need for x. You would find out that the final answer is 3.1% of 100 trillion numbers are prime. This formula is not exactly accurate, but it almost is 100%. There's only about a 0.001% difference. This formula saves you so much more time than counting 100 trillion numbers and figuring out which one of those are prime. Prime numbers are like a tree, that the closer to you are to 0, there are more prime numbers. The farther away you get from 0, there are less and less prime numbers. Another example is that if you wanted to find the amount of prime numbers between 1 and 500 trillion, you would plug in the numbers and find that there is 2.75% of those numbers are prime. So you see, this formula is so much more easier than counting all of the numbers one by one by one. It saves people a whole lot of more time and much more ease than having to figure out all of that. In conclusion, all prime numbers can only be divided by 1 or itself. Prime numbers are all odd except the number 2. Some examples of prime numbers are again 2, 3, 5, 7, 11, 13, and etc. The prime number theorem is a theorem to find out how many numbers are prime without having to count the numbers one by one by one. The prime number theorem is almost exactly accurate, but there is a 0.001% difference. Thanks guys for watching.